right, everybody. Thanks for joining us today. I was 10 seconds late on my start because, well, I was excited to see people in chat and in QA letting us know where they are. I always like to see where everybody's dialing in from. Makes the world very small and very welcoming to me, honestly. I'm definitely a citizen of the planet. And so thank you, everybody, for joining and taking time from your day to talk about this issue, the hot content problem and spiky traffic and what to do when, oh my gosh, all of a sudden I'm popular, or I can't predict workloads, or I have something that blew up that I didn't expect to actually happen for my application. And so really, really excited for you all to join us today. I think this is going to be a great session. I'm really excited for the content and the conversation that's going to happen. The conversation today is definitely intermediate to beginner. People ask us all the time, like, hey, can you let us know what this is going to be? My guest, Gary, and I are going to have a conversation about some of these things. We'll dive into some details here, but it's going to be more of a conversation just to set the expectation. And, I'll be lobbing some questions into Gary. We'll have a good conversation, but we are more than happy to have questions come from you all as well. And for the best questions, as always, what we do on these, we'll give away a copy of the definitive guide to CockroachDB, which you'll see a little picture of here on the screen. Thank God for our O'Reilly book. We got a cockroach on the front of it. It'd been really weird if we didn't. So, and then finally, the webinar is recorded. Before anybody asks, it'll be available a little bit later today. I think typically we stream to YouTube in many of these instances as well. And once we do that, well, it's there very quickly. So, but the team works to get this thing out there very quickly. So if there is something that you wanted to review or pass along to somebody, definitely our YouTube channel is a good place to go check those things out. And we're really good about posting these things pretty quickly. So with that, I'm going to come on video, I should say. Gary, do you want to join me here? All right. Actually, so welcome everybody. Actually, I think they got my title wrong here. I'm actually principal product evangelist. Definitely not I'm not a dev advocate anymore because I don't code. Gary, you code still, probably. I don't do that stuff, but I just talk. Evangelist and advocate is like different things. I'm an evangelist. But Gary, welcome to the show. Welcome to this session.
Hello, Jim. Thanks for having me. And yeah, I do a little bit of coding these days. Maybe a little, not quite as much as I would like to, but still enough. Still getting my hands dirty.
Yeah, I still play. I taught myself Go about a year and a half ago, and I love it. And I look for opportunities to go out there and actually learn it or use it. So, everybody, again, thanks for joining us. Gary, just by way of introduction, what we're going to talk about today is hot content, spiky workloads, and these sort of things. And so, just to give the audience a sense of who you are and your past. Let's just start off with can you just give me an overview of where you come from, Gary, and why you're kind of a valid person to talk about this sort of thing?
Sure. So, most of my career has been in backend services. So dealing with, infrastructure and delivering data actually to various different applications we use it, because as we all know, the world runs on data.
Yeah.
And without data, you can't really do a whole much. Been working in media companies for the last decade plus or so. Then most recently, before joining, Cockroach, so Hulu. Before that was at Disney. Before that was at Nintendo. So dealing with a lot of companies that deal with, media, entertainment, and dealing with consumers and getting out content. And so in all those places, we've had to deal with moving lots of data in various, incarnations, way back when it was getting data for, analytics, worked on Club Nintendo, where we pulled a lot of data out there. Very popular back in the day where people wanted to look at getting products from us, and then worked on a consumer product when I was at Disney that, was consumer facing. And we always had issues. We were planning for issues such as, on product launches like Christmas, things where, events where people would hit our services and hit our interfaces to get access to what they bought. And so again, dealing with a lot of data. And then obviously most recently at Hulu, where we're streaming a lot of information. And as some of there's a lot of good, television, video content out there these days. Some of it's really popular. I think Game of Thrones was mentioned. That wasn't Hulu, but Game of Thrones was mentioned in the webinar description, but Hulu we definitely had our own large events like the Super Bowl, coming over live TV. And so, I've been most of my career, the last decade or so, dealing with moving content around and moving data around and dealing with how to get that to various places, different people, and in various capacities. So we're talking about spiky content, spikes. It can come in lots of, whether it's a crush of people coming in, whether it's a lot of information you have to move from one source to another. It's all related and yet all just a little bit different.
Yeah. Well, we've come a long way. I mean, gosh, I remember when websites used to come down just like a static website. You know what I mean? Like,
oh, yeah.
Like the Silverlight plugin screwed something up, or like, you know what I mean? Like it was crazy back then. And we've come a long way, and I think tech has come a long way. And it's Gary, you've been at the front line of kind of like dealing with these sort of problems, and that's why we wanted to have this conversation today. Y'all. So, Gary does have some great experience in doing these sort of things. But Gary, what is your role is a little bit different here at Cockroach Labs. Yeah, you're doing something a little bit different this time around.
It's a little bit different, still related, in some of the core aspects. Like I come in with Cockroach Labs as a services engineer. So I'm working on our cloud offering, our cloud product. So taking our database, making it available as a SaaS product. So it's a little bit different than what I've been in the past, in that I'm not necessarily dealing with consumer-facing products anymore, or general consumer-facing. I guess we still have enterprise, and our consumers are other engineers out there, right?
That's right.
But a lot of it is still kind of something similar though. I mean, we're dealing with moving data, like a lot of the concepts that we had in terms of like dealing with the resiliency that systems need to handle, for instance, large spikes in traffic. A lot of those tenets kind of translate to almost any type of service. And so definitely that's kind of where I'm at right now, is trying to help us build out our services offering so that we can handle larger and larger loads as we grow, and that we can put our best practices that we've learned over time in here, and bring our services platform to make it even more world-class.
Well, yeah, and I sorry, but developers are very discerning consumers, dude. They know actually how it works, Gary. So like,
very much.
I think consumers have no idea how it works. They just expect it to work as fast as Facebook or Instagram or something. But like, when your database doesn't work and you're a developer, it's a wholly other level of kind of concern, right? I mean, I think, and building these sort of things but I think it's almost every system these days that needs this sort of resilience and scale and being able to handle volumes, right?
Oh, most definitely. Like you said, developers are probably the most discerning consumers out there. Definitely that. But yeah, I mean, I think especially as the world, the internet has made the world smaller, right? And things that businesses that go out maybe 10, 20 years ago maybe had a smaller audience, have a much larger audience these days. Everything's global. You could have a product that you thought was local, and you can sell it halfway around the world. Right. Or you can have a service that you think only people around you will care about, but who knows out there, all the netizens out there might want to use it. Yeah. And so data and what backs it and how it stores it is crucial to everything that's out there. And so up until now, a lot of thought has been around like your logic, your business functionality, how to do things. But just as important is like, where's your data? How do people access it? How fast can you get to it? And is it safe? Like, can you lose it?
And I think the only thing that's changed, I think, honestly, over the past 5 years is I think every application has to think about this, at least at some level. Maybe not every application, but, I mean, anything that's publicly facing, definitely. Even internal apps actually have, this scale and spike problem, and how you deal with these sort of things, I think, to see you, Gary, go from something that's more like streaming and like it's very visible how these things work, to something more like a database. I think it's indicative of kind of where this is going. And I think we've got a lot of people on this call. A lot of people are very interested in this. I'm sure they aren't all working at streaming companies. You know what I mean? Like, I think we all deal with this. But so what were some of the general problems that you've seen in your past that kind of apply today? That, your peers that are on the phone, Gary, are all looking at this as well. Like, what were some of the general challenges that you saw kind of making all this happen? I mean, beyond like, yeah, I get it. Like, I release a new video, The Bear, let's just take The Bear because that's a Hulu content, right? Like, and it was really popular and they had to serve that up to a lot of people over the last month. You know what I mean? Like, I get that side of it, but like, what are the challenges internally with actually making that happen?
Sure. And yeah, I mean, bring out The Bear is a great example.
Right.
because it's it's recent, it's gone pretty viral and it's very popular.
Yeah.
But I think when we're talking about hot content, we're talking about scaling out the delivery of data, right? There's a certain aspect of it that's kind of sort of a solved problem already. Things that are like static assets, static web pages. We have CDNs out there that can deliver that data. Where a lot of the issue these days comes from is personalized data, dynamic data, things that change and things that you can't necessarily cache in one place and serve it to millions and millions of people, right? And that's where a lot of the challenges is for especially in the streaming services and also from other like business services out there, is that if you have data that needs to be personalized and has to be on demand or on the fly, you can't easily cache that. And so that has to be computed on the fly and based on data that's coming from various different sources. And so keeping track of that data, making sure it's up to date, understanding the trade-offs between like how stale can your data be? Like, is it okay if some data is out of date? Is it okay? Does it have to be real time? That's kind of where a lot of the challenges are these days, is understanding your data, understanding your workloads and what the requirements on it are. For some things, it's easy. For some things, it is kind of like static data where it doesn't change a whole lot. And for others, especially for things like, personalized recommendation engines, right? Like my set of recommendations on like Hulu are going to be different than yours. And getting that set of data out in a fast and responsive way is a challenge. And that becomes especially more of a challenge as you get more and more people coming in and more people using your service. How do you handle that load? How do you break up your your infrastructure? How do you break up your computation and your data storage to make it so that everybody has a good experience? Like nobody wants to wait 5-10 seconds for like their recommendations to load, right? Especially with TV.
Yeah. So Gary, as as like a backend infrastructure engineer, somebody who's kind of looking at it from like this point of view, right? Where there's a capability we want to deliver, right? Like I want to stream something. I want to allow people to make bets. I want to, you know what I mean? Like there's the thing we're going to do. And then the back end actually has to accommodate that at scale beyond handle spiky workloads. How as a, as an infrastructure engineer, put your infrastructure engineer hat on, right? Like, how do you help developers understand this, right? Because you just went through a very good characterization of like, hey, you kind of got to think about things a little bit differently on what you're trying to, how do you help developers who may not be thinking about a back end start to kind of consider these sort of things, Gary?
A lot of the way I approach it is just kind of like understand what we want to do. And, I think some of the things that I've learned over time is if you have a service that you're looking to scale and you expect to need to handle that type of traffic, one pattern that I've seen a lot is to, take a look at what your core capabilities need to be like. These are going to be read heavy, it's going to be write heavy, it's going to be both.
Yep.
Like, do you need to be able to handle updates in real time and get them out? Or are you okay with, handling writes and then serving the data back at a later point, maybe a little bit of latency there, right? And as you start thinking about that, you kind of fall into some natural patterns. Like, there's pattern there for a while, CQRS, at least kind of venture models. But what that can do is it can let you decouple your writes from your reads. And so you have, for a lot of services, you can have like a write path that goes in that writes your data into a data store. And then you have another path that just reads the data. And then what this allows you to do is you take your writes entirely out of the question of serving your reads, because most of the time, your spikes in data, your spikes in traffic are going to be from your reads, because people are going to want to be accessing their data all the time and be able to access it and view it versus actually trying to add to it or change it, right? And so if you can decouple your reads from your writes, that allows you to scale those independently. And you can choose different technologies for each one, like how you handle your writes can be very different from how you handle your reads, and it allows you to optimize them for what each system is best for.
Yeah, I always think about it like every application is comprised of many workloads. And each workload is very different in terms of its requirements of what the backend kind of data infrastructure needs to be, right? And I think that's kind of one of those things that not everybody, I guess as a developer, I never really thought about it, because back when I was a developer, I had like one database and I didn't even have like these choices, but today we have different databases for different jobs. And I think that's pretty important, you know what I mean? And I think when we think about the data of the application as well, I mean, there's kind of also a metadata layer going on here across all these things too, right? Like there's like take for instance, like streaming. Yeah, I need to serve up this content. Like, and so we got a lot of people asking, there's a request, there's like the CDN that's delivering, but there's like a kind of metadata layer in this whole world as well, right, Gary? I mean, that's something that also needs to scale, right?
Oh, definitely. I mean, data about data. That's kind of like the area I was concentrated on in my previous life. But yeah, I mean, not only do you have the data and the content that you're trying to deliver, you have the data about it so that your systems that control it can actually understand what they're trying to do.
Right.
And so that's also equally as important, if not even more so in certain circumstances, for how you're handling your systems and your services. And so whenever you're dealing with your services or your backend, you have to take that into account as well. How do you internally, how does this metadata that you're dealing with, how does your control data flow to other services that you've got? Now, if you've got a small system, maybe it's pretty easy. You have one database, right? And you can talk to it and everything gets from there. But as you start to grow, right, figuring out how to split that data out and figuring out how to flow it through different services as you pull stuff out, throw it into different regions. Like if you start expanding globally, like how does, like, for instance, if you're expanding into Asia, for instance, how is your data center in Asia going to be able to get the information from like a data center in Europe or the US, right? How does it get that information in a timely manner so it can actually operate on it effectively? So there is definitely a layer of outside of the actual content that you're storing, for whether it be video content for streaming or like photo content if you're like Instagram or whatever, right? There's another layer on top of that encapsulates all of that. So yeah, there's a lot of data flying around all the time, and figuring out where it goes and how to handle it is key.
Yeah, I always like to think about like this, this consistent metadata layer that runs across all the things, which is actually pretty important. We've had, I've had other conversations around that. Our friends at Starburst use us like that. There's a lot of different companies do that sort of thing. And definitely CockroachDB has its role in that. You said something interesting though about, multiple regions and these sort of things, when you're running with a streaming service, how did you guys think about that, right? Like, did you have content set in different parts of the globe? Like, what does that architecture look like? Somebody had asked about that. In the QA. I'm curious as well, Gary, like how does that work?
So in my experience, a lot of it's still under development, but what we talked about is, what I talked about, like for instance, earlier, separating your reads from the writes, right? What that allows you to do is you can handle your writes in a certain or limited number of locations. So you don't have to necessarily have to have them serving everybody locally all the time. And so that kind of helps. And a lot of it comes back to just understanding what your writes have to be like. For instance, if it's telemetry data, right? Or if it's like metrics data, that some stuff that doesn't have to be real time, you can kind of handle it in like a small number of data centers that say, instead of like being in all of your data centers.
Right.
Like, for example, let's say you have a really large application and you're in 10 regions around the globe, right? Maybe you only have writes handled in 3 of them. So that you want multiple ones for redundancy, so that if one goes down, it can fall over. But writes in general, they can probably survive some latency, and also depending on the type of writes you're doing, like if it's telemetry measures, maybe it's best effort. For other areas where it's more like important, like for instance, profile data, account data that you're doing writes, then you definitely want to have like those more localized into your local region and have those set up similar to your read clusters, so that they're handling the important data and then you get it real time. And for that, you have to architect your systems a little bit differently, in that you kind of want local control for whatever region you're in for that set of data, right? And that can be difficult in a lot of databases, data stores, because trying to get that data written locally and then propagate it to the rest of the world is tough, right? I mean, you've got data contention, you've got locks. It's like, what happens if somebody accidentally writes into that data, that area from another region, right? How do you deal with that? And so there's a lot of different ways to handle that. I think geolocating data, being able to pin data in a certain region is key and helps that. Other things you can do are also like proxying some of the data, staging it, taking the writes, staging them, and maybe not making them permanent, having other ones. They're all fairly complex. Unfortunately, writes are hard.
Some are more elegant than others. I work at Cockroach Labs, y'all. So like, honestly, and Gary, I know you and I will talk about that. But before we get to kind of Cockroach and its role in this and kind of how that might work, just one other question in that context. It's interesting. These conversations I have with people who have actually done these sort of things, there's an emerging pattern across all of you, and it's like, well, write database for the right workload is what you're talking about. Right? It's like, yep, okay, I have a CDN that's serving up massive, huge amounts of content, or maybe it's Redis because I have odds that are being delivered in real time for an online betting application, but like the transactions are still going through and a relational transactional database, you know what I mean? Or like, maybe content's just being served up by a document store. Like, I think the key takeaway that I've had over the past, like a lot of these conversations, like right database, right workload, which comprises a larger application, which is kind of one of these things. And, we start to think about that, we start to think about spikes across those various different types of things. Like a CDN is kind of built to deal with that, right? Like a Redis is kind of built to deal with that. Like, Kafka and somebody's asking about streaming content between systems, like it's kind of built to deal with like, queues and real-time type of stuff. When you start to think about the transactional store and, separate reads from writes, how do you deal with spikes? Like, because that is like the main kind of concept here of the webinar, I know it's a tough question, Gary, but like, what are some of the things you think about?
Oh, definitely. So I think traditionally one of the weaknesses of transactional databases is because everything needs to be in one place, right? You have you get into situations where a lot of applications depend on some fairly complicated queries. And that's really where a lot of the contention in databases and performance issues happen when you're trying to scale out, is if you have a lot of very complex queries going to a database, that can take some time as they come up. And so strategies that I've seen in the past to help handle this are, you kind of take some of the data that you're working with, instead of having them in a single cluster, a single database, you kind of fan it out to multiple different, clusters, multiple different databases, each one local to their own region. And so you kind of localize your performance cost on them. So instead of having one database that serves everybody, you have one database that kind of serves as the master. This is where the writes go to, but then you have that replicated out to various different other databases or data stores out there. They don't even have to be the same database. Whether you can use, for instance, Kafka, like you can push data into Kafka and that goes out to other databases or other services that you have. You can push it out to even like file systems like S3 if you have a set of data that you want to do on there, or you can just replicate it out to different clusters. Like I've done that before. It's like you have one data store that's just in multiple regions, and you replicate your data out, and those other regions are, say, read-only slaves, right? And so they're there. And so what you do is you kind of localize your read hits into your local region while you're preserving your main database to handle your writes. So that kind of separates it out, and that brings another layer in there. What can also help on that is once you get that layer in there and you've got your data in another store, then you can start looking at, putting a caching layer on top, right? Where you can start customizing those local database data stores you've got. I'll call it the core on the edge, right? So you have your core database in the middle of your core. You've got, your kind of other local data stores outside on your edge, actually serving your customers with your reads. And once you've got that, you can customize them such that, certain data stores are more optimized for certain types of queries. Right. If it's relational, if it's like a lot of relational queries, they can be in a relational data store. If it's more, just key value lookup or document store, you can have a key document store lookup there. But once you do that, you have a lot more options. You have a lot more flexibility in terms of the systems you're building.
Well, Gary, I want to turn this a little bit into kind of how Cockroach actually helps address some of these things. But you said something really interesting there. It's kind of like, well, you don't have to have everything sorted at the very beginning. Like you're not going to have it all sorted. You're going to make changes along the way, right? And I think it's about minimizing the technical debt at which you kind of invest in early on in whatever project you're going. I think that's such a key piece of any takeaway of any architectural conversation. Number one, right? And so, let's shift into Cockroach Labs and Cockroach Database. How does CockroachDB help one think through those sort of things day one, right? Because we always like to think about, we're good for you today, but also we'll grow with you. And so what are some of the characteristics?
Oh, definitely. I kind of wish CockroachDB was around, when I developed some of our services in the past, because there's some things that, CockroachDB makes really easy. I don't have to think about, obviously, aside from being horizontally scalable very easily across the cloud, right? Because that's a big win from an operational perspective. There's a lot of other features that we have that make kind of this type of distributing data process a lot easier.
Right.
For instance, we have multi-region replication, which if we want to stand up clusters in various places and we have multi-regions, it's very easy for us to do that. And also have them be multi-master, right? So you can write in any region. So we get failover HADR from that fairly easily. I think there are some other features we have that are very easy, make certain things very easy. For instance, like distributing data out, streaming data out, like our CDC, change data capture methods, right? Where we can push changes to our tables out via either Kafka or via other, file storage, so that we can get those events out, we can get those data changes out to other systems that care about it, right? And so they're not necessarily tied to always talking to the database. They can listen to a change feed and make their decisions on their own, which kind of discouples them from that situation, right? And you don't have to build that on your own. We kind of have that built in, and we have guarantees around the data that goes out. I think I alluded to it a little bit earlier, but like getting geolocated data, right? Pinning data. I know that's a big thing for, certain types of privacy compliance, right? Being able to pin your data in certain locations so that they're always going to the right place. Not only for, compliance, but also for locality, like performance. So if if your customers in a certain region are almost always going to your servers in that region, it's best to have the data locally for them there, right? And so there's a lot of features that we have that make thinking about some of these problems in terms of scaling out and horizontally a lot simpler.
And Gary, I always think about like when somebody adopts something like a Cockroach or any distributed database, I think the big shift they do is you not only have to think about the logical model, which is I think what we've all thought about, like, the ERDs and like all that stuff, and we're modeling these things right for our systems, but you have to start thinking about the physical nature of data as well, right? And I think the physical nature of data is the tough part here, because that's where these latencies happen at broad scale. And honestly, this is where like we talk about spiky workloads. I mean, it also has these ramifications there too, right? Because you don't want like everything coming to single data center. So you can spread that out over more nodes. You can actually eliminate like, the spikes across a single stovepipe, you know what I mean, for writes and that sort of stuff. And I think those are the kind of key things. When people are thinking about the logical model and then applying the physical model to that, how do they go about that? Is it like, okay, great, I'm just going to kind of have the database living where? Is it, the table by table thing we talk a lot about here? Like,
that's a tough problem. Yeah, that's a tough question. And it's something that I think—
I know it's a tough question. That's my job, buddy.
The database is definitely part of it, but I think holistically, being able to look at the system itself is really important, because like you said, data doesn't just live in the database. It needs to go out. So you need to look at like the size of your data, your data access patterns, and then also like how and what needs are. I've had experience in the past where we thought we had a good, distribution method for getting data out, and when we discovered that, there's certain situations where, we put some content on the wire, like say it was like a 1 megabyte message, right? And that fans out to 500 to 1,000, different other servers, and that just takes down our network interface, right? That's tough.
Right.
And so when you're building the systems, I think one of the tenets for me is just, if as much as possible, keep your data local, right? Keep the data local, keep the disparate pieces, that you're working with smaller, so you can distribute it, and you can, they're all across different nodes a lot more efficiently. And you're not stuck with a single large, object that has to move lots of different places, because the larger things are, the longer they'll take, right?
Right.
And once you can do that, you got smaller messages, you got them local, then you start keeping things internal to your own database, and that gives you the physical locality of what you got. Yeah. And if you can consolidate certain things, if you only have like a small number of backend components that need to talk to each other across region, right? Whether that be pushed from the core to the edge, or whether, maybe sometimes edge to edge for failover purposes, then you reduce a lot of the crosstalk you have, that regional crosstalk, and you reduce a lot of latency that you have to deal with on there.
And operational complexity is setting it up and managing the whole thing, which I think is kind of one of those things, like use the database to deal with a lot of that stuff. I think there's some power in Cockroach that helps, right?
Oh yeah, definitely. I mean, the fact that Cockroach can horizontally scale, we can bring up extra nodes and they tie in, and it seamlessly works to scale, I think is huge, because there's a lot of other data stores out there where scaling horizontally is not as easy, right? I mean, it takes downtime, or it takes a lot of time for replication to happen, or reshuffling of data. And the ability for Cockroach to be able to just spin up new nodes, rebalance across all of it, and just have it up and keep it online is I think key to being able to say, hey, you know what? Maybe we're getting hotspotted on like certain tables or like on certain nodes. Let's bring up some more, spread the load out. And that's a key way to help the physical nature of the database. In terms of like data stores and database, that hasn't always been the case. Especially with relational models, right?
Yeah.
I think that's one of the reasons why like a lot of the NoSQL models like gained in popularity because they were easy to scale.
Yeah. And it's interesting. I mean, Gary, I think it's one of these things that once people get more familiar with Cockroach database, they start to understand what leaseholders are, or, leaders are, and voters, and what, like a non-voting replica, and like how you can use these various different features to really tune the database to really optimize for performance. I always think about like, oh, look at my customer table, like that, those records live in regions, so that's very close, but like inventory is across the whole globe. It's a global table. And like, so there's things like global tables, there's regional by row tables. I can say the more advanced concepts I think are actually pretty important. And I think our docs, y'all, go a really far way to explain these things. If I don't, our docs team is amazing. Like it's incredible. And I think starting there to understand those kind of concepts are important. There's a couple of concepts like, as of system time, I think is one of those important things. Follower reads is one of those things. Like, how much do you kind of like have those in your head as you're kind of using something like Cockroach database, or is this just something you kind of change over time? You just become more familiar with those capabilities, Gary?
I think a lot of the advanced capabilities, like a lot of it depends on your experience and how and what type of scale you're already
right.
working. Like if you're a smaller, startup or a smaller company looking to expand, you're not necessarily thinking about those concepts yet because you don't need to. You don't really need those unless you've got like some specific customer need for it, right? But I think over time, as companies mature, as systems mature, those extra features become more and more important, like geopinning of rows, the system time basically going, system time snapshots, right? Being able to go back and look at data as a system time becomes more important as you're trying to do more complex things in the future.
That's right.
I don't think I necessarily think about them a lot, like when I'm debugging my day-to-day, but it's definitely nice to have for those instances where they will come in useful, because they're definitely, especially in transactional systems, right? There will be times when it's nice to have those features, and having them already built in is very useful. But yeah, it's definitely a developing, as you develop your application, as you mature, use cases for those pop up.
Yeah. So last kind of Cockroach explicit question. Y'all, I know we're at 30 minutes and I get it. Like, but I'm sorry, Gary's got a lot of information I'm trying to extract from the guy. So I understand if you have to leave, but we're going to continue on. I know some people have stayed on. So one kind of, I got about 5 more minutes, I think. We recently went GA with the serverless version of CockroachDB. And its ability to kind of handle spiky traffic. Can you just describe that to me, Gary, and how you think about that?
Well, serverless is nice. Again, like you said, to handle spikes, right? I think the beauty of having cloud and the beauty of not actually being tied to a dedicated set of hardware is that we can scale elastically, and we can if we find, or you find that for instance, there's a lot more data coming in, or there's a lot more reads, and the database has to handle it faster. Or there's like heavy compute, like there's some queries that are really important, but they take a lot of resources to do. We can scale that cluster out, and we can scale it up pretty fast. I think we have a blog post out that shows we can spin up a new, a new cluster in like, I don't know, it was like under a minute, in seconds, right?
Careful, because that's a tough one to do. They're always optimizing that. Exactly, Gary.
Oh, definitely. But similarly, when we expand, we can also like expand out that way, and that gives you a lot of flexibility. The biggest issues with spikes is you don't know when they're going to happen. Like traditionally, what you do to handle spikes is you look at known events, Christmas, right, Super Bowl. Those are large events. You're going to have lots of traffic coming in, and so you pre-scale your system to deal with that. You go, okay, we think we're going to hit this, so we're going to have to expand that. But if you don't hit it, you're paying for a lot of resources you're not using.
Yeah.
If you do hit it, that's great. Sometimes maybe you've underestimated and it goes even higher, right? What's nice about serverless is that it'll grow or shrink as you need to, and it can do it pretty fast.
Yeah. And I think the concepts that we've used to actually architect our serverless database I think are like valuable to everybody on the call, like whatever app you're building, like understanding kind of the ephemeral compute separated from this kind of persistent storage and those sort of things. Like, what are the things that have to be there all the time versus what are the things that I can scale up and scale down intermittently to handle spikes? And I think looking at your own application and understanding what is ephemeral versus what needs to be persistent and drawing that line is such a key characteristic of your application architecture. Back in the early days of Kubernetes, I saw a lot of talks from the Ticketmaster team, and Ticketmaster's not a company of ours. I'm going back to like KubeCons, and it was like, yeah, how do you deal with Adele tickets going on sale at 10 a.m. Like that's spikes. Well, they're using Kubernetes to deal with all that, and understanding kind of the ephemeral nature of the transactions, yet having a database that's going to scale to meet that. I know that like that's the problem. Like having both this ephemeral layer that's going to scale up and down, and having a database that can scale up and down to actually deal with that. I think that's such a really nice kind of like mix of two layers of a similar architecture.
Oh, definitely. Having the database, the data store layer be able to scale gives you a lot more flexibility.
That's right.
I think if you're stuck with a fixed data store and fixed size, then you're kind of reliant on having a compute layer, services layer that you can scale and be flexible with, right? And depending on your workload or your type of data you're dealing with, that may or may not be true. Like in some cases, certainly you can get away with that, but there are others where it just doesn't work easily that way. So having that flexibility opens up a lot more options to optimize your services and to be able to be more efficient.
Yeah. So I'm just, y'all, I know we're past time. I'm going to tackle a couple of these questions that came through. Y'all were asking about blog posts on these sort of topics. Number one, our docs do a great job. Excuse me. I literally had breakfast like 10 minutes before we started. Sorry, Gary. We do a good job on our blog about all these different things. And in fact, our team wants to engage with you on these sort of things, and people like Gary who have experience doing this. Our public Slack channel is another great place and a really, really good environment to have those conversations. And honestly, you'll actually run into your peers who are dealing with these sort of things as well. I think, there's things that we do within the database to handle spiky traffic that they can read about in our docs as well. The last question here, and it's kind of related, unrelated. I don't know, as an application developer, Gary, what platform do you think about when you're using CockroachDB? I guess IDE or like just language, like kind of like, is it everything? Like, is it optimal in certain languages? How do you think about that, Gary?
I mean, for CockroachDB, I think I don't necessarily think that there's a specific platform I prefer. I mean, there's definitely platforms that I'm used to with my own development, right? I come from a Java background, and right now we're using Go. And so those are the ones I'm most familiar with. But one of the nice things about CockroachDB is that we're Postgres wire compatible. And as such, for that, any Postgres client you can use to connect to the database. And aside from that, a lot of it is just the architecture you're building on, right? I don't necessarily think that one framework is necessarily better than the other. It's definitely more how you develop your services. Like, there are certain patterns in the Java world that you can follow that allow for, read-write separation. There's certain patterns in, say, Python, or, and then certain other patterns if you're more front-end or full stack. I personally, from what I'm familiar with, Java and Go probably are the platforms I choose. Again, that's just all because of familiarity and not because necessarily one is better than another.
Well, I think you nailed it. It's usually familiarity. And, like we've gone a long way to building ORMs. Like if you want to do that, like, just being wire compatible with Postgres is kind of nice. I even use these, I'm sorry, y'all, but like, look at, I don't code anymore. So I use these quick code, whatever, like the no code platforms like Retool and these others. It just works. I could have a serverless database and app up and running in like 2 minutes. It's kind of, so I think being wire compatible has been a good thing. I quite like Go, honestly. I like the concept of a threaded language. I like the these sort of things, kind of the synchronization of the approach across all of them is kind of great. So well, Gary, thank you for doing this. Any kind of parting words or, anything we didn't cover that was in your head? I know we talked a lot here, buddy.
I did, I just did a lot of talking. Hopefully, some people found it useful. No, I mean, I think, again, I think we reiterated it a couple of times and you brought it up a few times. I think the keys to a lot of what we're talking about is just understanding your data, understanding your workload, and then understanding your user patterns and access patterns, right? Because those are key to designing a system that handles and can, deal with whatever traffic or whatever situations that come up with, right? I think without knowing what your data is, without knowing like what it needs to do or how you're operating with it, and without knowing how it's going to be accessed, right?
Yeah.
It's very hard to plan around for any of these. Like all the tools we have, and this is true of any provider, all the tools that we have, like all the features we have, aren't going to be really useful to you if you don't know when they're going to be needed.
Yeah.
Right tool for the right job. And so understanding your own systems and architecting it in a way that takes advantage of the tools you're using, I think is key.
I think that's great stuff, Gary. Right tool for the right job. Number one, watch out for your technical debt, because changing things in the future could be difficult. And I always think like one of these key things, and I've heard this from countless people, communication up front. Like, I don't want to communicate through some like huge system failure because we had 8 million people come online. Let's not communicate in a post-mortem. What are the little things we could do up front to basically address these things longer term? And I think that's some of the stuff. Hopefully there was a few things that we spoke about here that might help people think about that. I do hope this was valuable to y'all. Gary, I hope you enjoyed talking. You didn't do all the talking. I mean, you did a lot. Yeah, you did a lot. It was fun though. So thank you, buddy.
Thank you, Jim. Yeah. You run a great ship.
Yeah. Well, thanks, man. I hope everybody, I was asking good questions for y'all. We had a lot of questions in the QA. Thank you, everybody, for doing that. Some stuff on chat and whatnot. So with everybody, thank you again for taking your time today. Hope this is valuable. Recording will be up very soon. Everybody out on YouTube, thank you for joining as well. And Gary, thank you, buddy, for doing this today.
Great. Thanks for having me. And thank you, everyone, for joining.
All right, y'all. Have a great day.